Hi students, and today I have come up with one more interesting topic from chemical bonding, that is Fajan's rules. So here what are Fajan's rules, how these rules are helpful to us. Here before going into these Fajan's rules, first I would like to discuss what is ionic bond and what is covalent bond. What is ionic bond and covalent bond? So here ionic bond, it is nothing but an electrostatic force, strong electrostatic forces of attraction between a cation and an anion. So here this ionic bond usually takes place between a metal and a non-metal. Metal and non-metal. Metal and a non-metal. Between that metal here, if you take NaCl, between the cation and the anion, there is a strong electrostatic forces of attraction. So, frankly speaking, there is no bond, as we are talking about the ionic bond, there is no bond between the cation and anion. It is just a strong electrostatic forces of attraction exist between the cation and the anion. Okay, between a metal, and it takes place between a metal and a non-metal. Now what is a covalent bond? Here the covalent bond formed by sharing of electrons between the atom. For example, you take hydrogen. So here hydrogen contain an electron. So here it don't want to lose that electron. Instead it want to gain that electron. Instead it want to gain one electron to complete its duplet. So here during the formation of hydrogen molecule, here these two electrons are here. The one hydrogen shares an electron with another hydrogen, and similarly this hydrogen also shares an electron with another hydrogen, forming a covalent bond. So covalent bond takes place by sharing of electrons, and here it is in the ionic bond, it is a strong electrostatic forces of attraction between the cation and the anion. Okay, got the idea what is an ionic bond and covalent bond? Here ionic bond is also called as electrovalent bond. Okay, and now here if you observe, any bond is not perfectly ionic and not perfectly covalent. Here ionic bond may contain some covalent character, and covalent bond may contain a partial ionic character. So here now this Fajan's rules helps us to find out the covalent character in an ionic bond. Got my point? So here these Fajan's rules help us to find out the covalent character in an ionic bond. Okay, so what is an ionic bond? It is a strong electrostatic forces of attraction between a cation and an anion, and here covalent bond is formed by sharing of electrons between the atoms. Okay, comparatively ionic bond, covalent bond is weaker bond. So just keep that point in mind. But although here it is an attraction, that is a strong electrostatic forces of attraction between the cation and anion. Okay, now we'll move into the Fajan's rules. Now let us take an ionic bond in which it is formed by the cation, small cation, and here it is a large anion. Small cation and a large anion. Here let us take an ionic bond which takes place between a metal and a non-metal. Here, and anion will be attracted by the cation. Will be attracted by the cation of smaller size. Cation of smaller size. So what will happen after some time? There will be here these electron cloud tend to shift towards a cation. So there is a distortion. Actually it is in the spherical shape. So here after some time there is a distortion in the shape of an anion is observed. Means electron cloud is shifting attracted towards the cation. This is nothing but the polarization of the anion. Polarization of the anion. Now, what is the role of cation here? Here, the cation should have the capability to cation polarizing power. Polarizing power of the cation and the polarization of the anion. Here, okay, now here when the electron cloud is slowly shifting towards the positive charge, initially it is an ionic bond. But here, what happens here? It tends to behave like a covalent bond. Sharing starts here. Means here, these electron pairs partially shifting towards the positive charge. That is nothing but polarization of the anion, and it is the ability of the cation. Means that is nothing but the polarizing power of the cation, which decides here polarization of anion and the polarizing power of the cation decides how much covalent character is there in an ionic bond. Got my point? Now we have to discuss the polarizing power of the cation and the polarization of the anion, and what are the factors influencing these two. Okay, those are called Fajan's rules. Okay, here when the now I told you the how much covalent character is there in an ionic bond, that is decided by the polarizing power of the cation and polarization of the anion. Polarization of the anion. So here now we'll discuss what are the factors that influence polarizing power of a cation. And the first one is the cation with a smaller size. Cation with small size. Let us take here if you observe among these three, here which one will have the strong polarizing power to attract the anion. Let us take this is the anion. So here if you observe the first one, here the charge is dispersed because size of the cation is more, the charge is more dispersed, and when compared to first one and the third one, here the charge is more concentrated because of the small size. So the attracting power of this cation is more towards the anion. So strongly it will attract the anion. So what will be the polarizing power? The polarizing power will be more, and more polarizing power, more will be the covalent character. CC means covalent character. More polarizing power, more will be the covalent character. So if you first factor that influences the polarizing power of the cation is a cation with a small size. Cation with a small size. So here the cation with a small size have the ability to attract the anion towards itself. So more stronger it will attract the anion, more will be the polarizing power, more will be the polarizing power, more will be the covalent character. Okay, so this is the first factor. And the next one, cation with more charge. Cation with more charge. So here let us take the cations with more is the charge of the cation, more is the charge of the cation, more it will attract the anion, obviously. So here among these 1, 2, 3, more charge means more positive charge, more it will attract the anion. So here more charge on the cation, more charge on cation, more is the polarizing power, more greater will be the covalent character. Okay, what is the second factor? Cation with a small size and cation with a more charge. So here, if the charge of the cation is more, then it will attract the anion easily. It will attract the anion easily, and more will be the polarizing power, more will be the covalent character. Okay. Now, the third important and interesting factor which influences the cation is the cation with pseudo inert gas configuration. Cation with pseudo inert gas configuration. Pseudo inert gas configuration. First, what is inert gas configuration? Here you know noble gases: helium, neon, argon, krypton, xenon, radon. So here, why these are called as the inert gases? Because they are having the stable octet configuration, 8 electrons, they have completed their octet, so those are called as inert gases. So here, what is the electronic configuration of this one? So here it is 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 5s2, 5p6. So 8 electrons in it, outermost shell. So the octet is completed. Neither it will lose electron nor it will gain electron. So they are called inert gases, noble gases. Noble gases are also called as the inert gases because of this electronic configuration. Now what is the pseudo? Here inert gas configuration means 8 electrons in an outermost shell, and pseudo inert gas configuration means here it is 18. If any cation with 18 electrons in its outermost shell, that is called as pseudo inert gas configuration. 18 electrons in its outermost shell. For example, let us take copper with an atomic number 29. Now write down the electronic configuration for this copper. Now copper with an electronic configuration 1s2, 2s2, 29 atomic number, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. So here it is anomalous behavior of copper and chromium while writing the electronic configuration, because here anyway completely half filled is more stable and completely filled is also more stable, like this. This is completely filled and completely half filled. So here in the case of chromium 3d5 4s1, you can observe. After the class you can write. Here the chromium electronic configuration will be 3d5 4s1, because here completely half filled, that configuration is more stable. Here it is completely filled. So here copper with this electronic configuration. Now you write Cu plus, copper plus, loss of this electron. Now write down the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Now how many electrons are there in the valence shell? So here 10 plus 8, 18 electrons. So now my third point is cation with pseudo inert gas configuration. So here any cation with 18 electrons in its outermost shell that has more polarizing power, greater will be the covalent character. This I want to tell you. Okay, the first factor which influencing the polarizing power of the cation is size. Smaller the size, the stronger it will attract the anion. More it will attract the anion, more will be the polarizing power, more will be the covalent character. And the second point, the cation with more charge. More charge means more positiveness. So with the more positive charge, it can easily attract the anion. So more will be the polarizing power, more will be the covalent character. And the third one, cation with pseudo inert gas configuration. I told you what is an inert gas configuration. That is for the noble gases, group 18 elements. Here they are having 8 electrons in its outermost shell. So it is considered as the stable configuration, and because they are called as inert gases. So here pseudo inert gas configuration means 18 electrons in its outermost shell. So copper with an atomic number 29 with this electronic configuration, and Cu plus means loss of 1 electron from the outermost shell. And now how many electrons are there? 18 electrons. Now any cation with 18 electrons electronic configuration in its outermost shell is has more polarizing power, and more will be the covalent character. In that line, here copper, down to that copper, silver and gold. So these are having the electronic configuration. These are having the electronic configuration of. Here copper belongs to 3D series. It is 3s2, 3p6, 3d, 3d10. Now it is 4s2, 4p6, 4d10, 5s2, 5p6, 5d10. So if any one of these cation is present in your question, that cation with the pseudo inert gas configuration that has the more polarizing power, more will be the covalent character. Clear? And like this, zinc also. Zinc with an atomic number 30. Write down the electronic configuration for the zinc. Now zinc 30, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, and it is 4s2. Now write down the electronic configuration for Zn plus 2. It is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So 18 electrons in its outermost shell. Down the group, zinc plus 2, cadmium plus 2, Hg plus 2. With this configuration, here it is 3s2, 3p6, 3d10. It is 4s2, 4p6, 4d10. Here it is 5s2, 5p6, 5d10. So here the elements with pseudo inert gas, the cations with pseudo inert gas configuration are copper, silver, gold. Copper, silver, gold. And next, zinc plus 2, cadmium plus 2, Hg mercury plus 2. These cations will have more polarizing power, more covalent character. See, covalent character. So these are the three factors which influences the polarizing power of a cation. Okay. So the next factor, polarization of the anion, and what are the factors affect the polarization of the anion. So in the cation we have discussed the size of the cation. In the case of anion also, it is the first factor, size of anion. It is obviously, if the anion is with the more size, then it will attract the, or it will attract the, here this is the anion with the small size and this is anion with large size. So here it is the cation, obviously with the small size. So which one will polarize easily? Here the anion with the more size. So more will be the polarization or the distortion in the structure. Basically it is, I told you, no, it is in the spherical shape. So here while it is approaching the cation, here there will be a distortion in the shape like this. So that we call as the distortion in the shape, we call as the polarization of the anion. So here the more is the size of the anion, the more will be the polarization and more will be the covalent character. Clear? Okay. Next, second factor, charge. This also you can easily guess. Here the more charge, more means more negative charge on the anion, more it will attract the cation, more will be the polarizing power, and more will be the covalent character. These are the two factors. Now what are the Fajan's rules? Here Fajan's rules first help us to find out the covalent character in an ionic bond. I told you, no, here no bond is perfectly ionic and no bond is perfectly covalent. So here Fajan's rules helps us to find out the covalent character in an ionic bond. So here ionic bond is formed between a metal and a non-metal. Okay, I am revising the points. Metal with a small size cation and anion with a larger size. Ionic bond is formed between the metal and non-metal. So what are the here? The anion approaches the cation, there is a distortion in the structure. What are the factors affect in the case of cation? As usually the size of the anion, size of the cation. Smaller the size of the cation, the more will be the polarizing power, more will be the covalent character. And charge, more is the charge on the cation, more will be the polarizing power, more will be the cation. And the cation with the pseudo inert gas configuration: copper, silver, gold, zinc, cadmium and mercury. If the cations are with this pseudo inert gas configuration, the polarizing power will be very high and the covalent character is very high. And next, anion. The size of the anion, if the size of the anion is more will be the covalent character. And the charge also, here more charge, more will be the polarizing power, more will be the covalent character. This is about the Fajan's rule. Okay, in the next class we will discuss applications or the examples of the Fajan's rule. Okay, bye.